Okay, for lesson 2 right here, we are going to go over two big ideas. I just want to review something that you might have learned in Algebra 2. We will have even and odd functions, and then we have operations of functions. We will go a little bit out of order today. So we will first focus on the bottom half of the notes. We'll go to the operations of functions first because it's easier. It's a lot easier, okay? And then we'll go back to investigate and to find out what it means to be an even function and to be an odd function. Okay, so operations of functions, it's pretty straightforward because it's quite self-explanatory. The only thing that's challenging, well, mildly challenging, is that the notation. So let's go ahead, take a look at the notation right here. And we say, well, for the first one, we have f plus g, and then inside the parentheses, and then we have x also in the set of parentheses. Now, the way we say it, okay, and I would strongly encourage you to say it too. We say f plus g of x, f plus g of x, okay? That's what we say for the things on the left-hand side. And the actual meaning is that, well, it's just f of x plus g of x, f of x plus g of x, okay? So that's what it means. It's just a notation, okay? Of course, later on, we may see things that are slightly different. We may actually have a value that's in the place of x, okay? So, well, we just interpret it the same way. So f plus g of x means f of x plus g of x. All right. Now, well, if you understand this, then you will probably understand the one on the right-hand side, the subtraction one. So f minus g of x, f minus g of x equals to f of x minus g of x. Okay, f minus g of x simply means f of x minus g of x. So just make sure that you know that you have seen something like this and you know what it means. That's really what it is. Okay, just make sure you understand the notation. Now let's switch gear to multiplication. Well, I would like to apologize right here that the dots that you see right there, it's a little bit lower than it should be. So if you may, you can just go ahead and rewrite this and put the dot a little bit higher so that it makes it looks more like a multiplication than a decimal point. So f times g of x, it's equal to f of x times g of x. Okay, that's what it means. Very straightforward. Okay, and then on the right, we have f divided by g of x, simply means f of x divided by g of x. Now, you may see that at the end of it, there's a little thing right here. It says g of x cannot equal to 0. Well, the reason why we have to write this kind of condition, it's because, well, what you see is a fraction. And with a fraction, we clearly do not want the denominator to be 0. Because if the denominator is equal to 0, then the whole fraction becomes undefined, and we do not want our fractions to be undefined. So that's why we will just put a little statement at the end and say, hey guys, please make sure that when we put in g of x, it does not equal to 0. Okay, the whole g of x will not equal to 0 in this case. Okay, we do not want the fraction to become undefined. Okay, so all right, so pretty straightforward. Now we will again go a little bit out of order. We'll come back to the to this example because if we do this example, we're gonna decorate the graph paper, the graphing area down there, and we actually need to use these lines. So to avoid getting ourselves confused, let's go ahead and focus on the bottom 4 sample questions down there. Now, so the 4 questions are just practicing what you learned from the notations above. So, so if you could, you may pause the video for a moment and then go ahead and try these questions yourself. And then when you're ready, you can resume this video and then and we can check the answers together. Okay, assuming that you have all the work done down below, let's go ahead and focus on the notations first. So f plus g of 4 simply means, oops, sorry, it simply means f of 4 plus g of 4. Okay, f of 4 plus g of 4. Well, where's f and g? Well, it's the graph above. Okay, so the graph provides us the values for the function f and the function g, and we look at function f. We say, what is f of 4? Well, the meaning of this is simply that, well, if x is equal to 4, what is the function value, or what's the y value? The function value. So we say, oh, right here, I can see that it's equal to 0. Okay, and remember from last lesson that a good habit to have throughout this course or throughout your math learning journey is that whenever you do substitution, it's a good idea to use a set of parentheses to make sure that it is not confusing yourself. Okay, so if 0 plus, and then g of 4, and g of 4 is right here. Okay, g of 4 is right here, so it is equal to 1. So the addition is simply 0 plus 1, which is equal to 1. Very straightforward. So the only thing challenging right here is, do you know how to interpret the notation? And also, do you know how to look at the notation f of 4 and find out the corresponding function value accordingly? Okay, if you know how to do these two tasks, easy stuff. All right, let's go ahead, take a look to the right-hand side. It says f of 3 minus f of 2. Ooh, that's even easier because we don't have anything much to interpret. So we just need to go to the graph and say, hey, what's f of 3? And hey, what's f of 2? It's a, oh, x is equal to 3. What's the function value right there? Well, look at the function f, the graph, and we say, oh, when when x is equal to 3, the function value is 1. So we write down 1. And then what happens when x is equal to 2? Well, if x is equal to 2, the function value is 3. So we have 1 minus 3, which gives us minus 2. Minus 2. Okay. All right. So pretty straightforward, easier than the previous one. And over here, we have f times g of 1. And again, apologize for this a little bit misplaced dot, which stands for multiplication. So just to make yourself less confused, I put it f dot g and then of 1 right there. So in terms of notation, it simply means f of 1 times g of 1. So f of 1, let's see, what is f of 1? It's right here. So f of 1 is equal to 2 times g of 1, which is equal to 1. So we say, 2 times 1 is equal to 2. Okay, very straightforward. Make sure you have good handwriting and good habit of writing notations. There's nothing to rush, actually. Just make sure you write the notation. Okay, it doesn't give you bonus points if you skip these crucial steps here. And then for the last one, we have f divided by g of 5. That means we have f of 5 divided by g of 5. Now, if you have done this already, you may find yourself in a little bit of a dilemma because if you look at the graph, you're like, wait, hold on. This is 5. This is 5. Where's the graph? The graph stops at 4. And we're like, there's no value. There's no value here for both f or g. So what does it mean? Well, it means that, well, we don't have a value. So we call it undefined. Okay, we just simply don't know. We simply don't know what it is. So we say it's undefined. Okay, so right there. All right. Now, let's go ahead and talk about the local minimum and local maximum and absolute minimum and absolute maximum. So when we look at a graph, we will let you know where is the highest point and where's the lowest point. And as you can see from the graph right here, sometimes it goes up and sometimes it goes down. So let me go ahead and clear up the dots right here so that we can see a little bit better. And okay, all right. So let's put our focus to F because you can see the ups and downs. Now, how do we define local minimum and local maximum? Well, if you look at the word local, that means it's like, you know, it's specified, it's restricted in a certain area. So it's like locally, hey, that's a minimum. So in order to be a local minimum, it must show some behavior like this or like this. Okay, it has to go down and has to go up. That's what it means to be a local minimum. And for a local maximum, well, it must have to go up and it goes down. Or if it's a straight line, it goes up, it goes down. So now, let's look at this together and look at just, let's just use F for our example here. We say, where is a local minimum on this function F? Okay, where's the local minimum right here? And we say, hey, guys, can you see this? Can you see the local minimum right here? Okay, when x is equal to 0, right here. When x is equal to 0, it has a dip and then it gets back up. So we call this point the local minimum. Now, in the future, you may also see another way to call this a local minimum. We may also call this a relative, okay, relative minimum. Okay, so we can call this a local minimum or a relative minimum. Okay. And what about the local maximum or the relative maximum? Well, we can see that for function f, we can see it right here. Okay, we can see that right there. Okay, when x is equal to 2, hey, we have a local maximum at a value of 3. Okay, so we call this local maximum, or we can call it relative maximum. Okay, so it's like, you know, compared to the left, compared to the right of this point, this is the highest point. So we call it the relative maximum. Pretty straightforward. Okay, it shouldn't take a lot of memory, okay, to understand the materials here. Local means a localized region. So just at that spot, it goes down, it goes up, or it goes up, it goes down. Then you call it minimum or maximum. All right, so that's pretty straightforward. Okay, so so now we will take a look at the absolute minimum and the absolute maximum. Now, well, if you look at the word absolute, well, you can think about what it could mean. I mean, you know, for the entire graph, where is the graph that is absolutely the highest or the lowest? Okay, so if you look at the function f, where is the graph that is absolutely the lowest point possible? All right, I'll give you a moment to take a look at the function f. Can you locate the lowest possible point, okay, for the whole graph? Okay, take a look. Lowest possible point. And it shouldn't be that hard to find out that for function f, this must be the lowest point. So we say that, hey, it has an absolute minimum when x is equal to 4. And the value for the minimum, it's 0. Okay, and that's for function f. Okay, only for function f. Okay, and for the absolute maximum, take a look. Where is the where's the absolute maximum? Where is the highest possible point? And if you take a look at it, and you will find out that we actually have 2 x values that shares the absolute maximum of 3 up there. Okay, so we call it the absolute maximum. Okay, for these 2 points. So when x is equal to -1 and when x is equal to 2, they both achieve the absolute maximum of 3. Okay, let me label this as well. So it's very simple. In terms of the meaning, okay, absolute minimum and maximum, it simply means, hey, where's the highest and the lowest possible value for the whole graph? And in this case, the endpoints could count. Okay, the endpoints could count because we're looking at the entire graph. But for local minimum and maximum, you can see that, well, the endpoints cannot be local minimum or maximum because it has to show this kind of a change of trend. Okay, it has to take a dip, it goes back up to become a local minimum. It has to go up and then goes back down to become a local maximum. Okay, so if you take that as an observation, you can say that, oh, okay, it is important to analyze the endpoints and when we take a look at the absolute, since we just look at the whole function, look at the whole graph. So it's pretty straightforward. Okay, so we have that right there. And let's go ahead and clear this one out real quick so that we have a clean graph to work on the next portion. Okay, so let's go back to this example up there. It says the graphs of f and g are given. Graph f plus g of x on the same set of axes. Okay, graph f plus g of x on the same set of axes. So now, we just want to add these two functions together. So we have f of x plus g of x. In this case, we are looking at all values of x, not just a particular value or two, but all values of x. Well, does that mean that we have to do a lot of calculation to make this happen because it applies to all values of x? Well, the good thing is that we are just looking at some linear straight lines. Okay, so the points that we have to really worry about would be the points where it changes direction because it may change its interaction with the other function. So whenever you see a point right there, it changes direction. So we have to recalculate the sum between the two functions. All right, so let's start from the first point. We say, right here, okay, right here, f value it's 3. Okay, so when x is -1, f is 3, and g is -1. So we say, so when x is equal to -1, f is equal to 3, and then g is equal to -1. So 3 plus -1 is equal to 2. Right there. So we put a dot right there that represents our f plus g of x. Okay, that is our dot. And then we move forward to x equals to 0 because f has a change of direction. And we say, right there. And when x is equal to 0, what is f? F is equal to 1. What's g? 0. So we add them together, we have 0. Oh, no, sorry, my bad. It's 1. Okay. So now we're going to do all the dots first, and then we connect the dots at the end. That would make our life easier. Okay. So we move forward. Okay, we move forward to x equals to 1. When x is equal to 1, f of 1 is equal to 2. Okay, and then g of 1 is equal to 1. So that gives us the value of 1, 2, 3. So 3 right there. We put a dot right there. Okay, and then we keep going. We say, all right, when x is equal to 2, what is it? X equals to 2, f is equal to 3, and then g is equal to 5. Ooh, that's a much bigger value this time. So we have 8. So we go ahead, put a dot at 8. Okay. Next up, we have x equals to 3. Okay, x equals to 3. So f equals to 1. Oh, sorry. And then plus g of 3, it's equal to 3. So we got 4 right there. Okay. And last but not least, we have the last point right there. The last point is when x is equal to 4. Let me go ahead, shift up the work right here so they got a little bit more space to do my work. And when x is equal to 4, f of 4 is equal to 0, and g of 4 is equal to 1, so it's equal to 1. So we put a dot at 1. And with all these points plotted, and now we can carefully join these dots together with straight lines. So, and we could also, we should actually label this line with f plus g of x so that people would know that, oh, what's that line? Oh, that line, it's the sum of f and g together. All right. So that's really it for the operations of functions. So just to give you a quick recap, and that is, well, first you must know the notation. Make sure you can interpret them properly and correctly. And we have f plus g of x simply means that we have the two functions added together. And a side note right here, we tend to use f and g for the functions, but it is very possible that we use other names, other letters for functions. Like later on, you may use h for height, a capital H for height. You may use capital T for time. You may use P, capital P for profit. Okay, so we have all kinds of letters. Okay, the point is that the notation, we have two different functions. If we add it together, this is what we write. Okay, and we have addition, we have subtraction, we have multiplication, and we have division. So the key thing right here is to make sure that you know how to interpret these functions. And then we may give you a graph, we may give you a table, or we may give you equations for those functions. Then the key thing right here is that if you have these things right here, you interpret the notation properly, and then you find out the corresponding values correctly and accordingly. And then you just compute and find out the sum, difference, product, or the quotient. And that's it. That's pretty much it for the operations of functions. I think everybody should be able to handle this and achieve excellence on this topic. Okay. For the next video, we will go ahead and talk about the even function and odd function. You would probably need, well, you will need a piece of paper. Graph paper preferred if you have it. If not, a college rule loose leaf paper or your notebook paper would work. Okay, so take a break and then we'll come back for the second round.